Okay guys, I told you we'd do a video lecture on displacement versus distance. So if we start off here where X marks the spot, and I were to travel all the way around in a circle. Imagine that you're running laps, let's say. Only your track is actually circular. Okay? If you run all the way around and you head all the way around the circle and end up back where you started, the total distance that you covered would be given to you by however many meters around that circle, right? So distance equals, what's the circumference of a circle? It's 2 pi r, where r is the radius. Okay? So if I said this was my radius and I traveled all the way around that circle, then the distance that I covered would be 2 pi r. My displacement, though, is how far I've moved from where I started. Okay, so displacement is how far from starting point. Okay, so if we start at the x and we end back at the x, we started and ended at the same point. So for this case, it's 0. Okay, so for a round trip, our displacement should be 0. Okay, and if we think about it in terms of what we do every day, it's kind of a little depressing. So you get out of bed in the morning, you go to school, you wander all around the school, you run around this track, you head home, you do homework, and you wind up back in bed. You've had 0 displacement. So the net effect of the day is a 0 displacement. That doesn't mean that you didn't cover a lot of distance, but your displacement was 0. So for the lab that we did the other day, what if we took it and we said we were going to stop part way? Remember I said you had to pick some place that you were going to end up. So let's say that you started off at room 55. Okay, and you ended up, I don't know, over here at the cafeteria. Okay, so you end up at the cafeteria. Well, that's a different ending point than what we started off at, so we do have a displacement. Our distance would be half of that trip. So distance equals 1/2 times 2 pi r for this case. But our displacement is just from where we started in a straight line to the cafeteria. Okay, it might be hard to tell in the video, but that's actually purple. Okay, so this would be my displacement. So for this case, displacement straight line path from where we start to where we finish. Okay, and I say where we finish because where we finish, well, we can pick that arbitrarily, right? I let you guys pick. For some of you, it might have been the cafeteria. For others, it might have been the village. It could have been, I don't know, Miss Bishop's room, someplace over here. It could have been the theater someplace. It's just all dependent upon where you guys wanted to go. Okay, so you get to pick where you finish, and that's important later on when we start going into some more complicated equations, because you get to pick what your displacement is. And that's going to affect how long it takes you to get there, right? Okay, so keeping in mind distance and displacement are two totally different things in most scenarios. Okay. What we did yesterday is you recorded your steps in east, west, north, and south directions. So for our class, we're going to use our y-axis in red and our x-axis in blue. So when you guys went however many steps north, this, the origin, is going to be room 55. Okay, room 55 or starting point. Okay, so for our case, it's room 55. So if you traveled, let's say it was, make it something reasonable. Okay, let's say that you went 100 meters to the north. Okay, so we went 100 meters north. Okay, and then maybe you turned and you went, 50 meters east. 50 meters east. Okay, and you'll notice my y-axis up is north, down is south. My x-axis to the right is east, just like you'd see on a map, and to the west is left. Okay? So I went 100 meters north, 50 meters east, and then I turned and I went, let's see, when I took my steps and I calculated it out, let's say that I went 90 meters south. Okay, does it make sense? I went south from where I left off here, not south from the origin. So 100 meters north, I turned, I went 50 meters east, then I calculated that I went 90 meters south, and then I said, well, I went 45 meters west. I have a problem, right? I wound up back at room 55, but my calculations that I did in my lab would say otherwise. So according to the lab results, it says that I wound up here, but I know I was back at room 55. So there's some sort of error, probably that I don't walk perfectly equal every single step. Okay, so 100 meters north and 90 meters south means that I went 100 meters north. Remember we talked about in the notes that north is a positive, okay? And south we take to be negative, plus negative 90 meters south, okay? So I can kind of drop out the north and south part now because I accounted for that with my signage, my plus and my minus. So 100 meters minus 90 meters, right? Or 100 meters plus a negative 90 meters. Same thing. So that equals a total of positive 10 meters in the y direction. Okay, positive 10 meters is the same thing as saying 10 meters north. So I was off by 10 meters in the y direction. Then if I look at my x, my east-west, well, I went 50 meters east. So my x direction, 50 meters east, which is positive 50 meters. And we're going to drop off our east because we're accounting for it with the sign of positive. Okay, and then plus, but wait a minute, that one's headed west. And we said in the notes that west was negative. So plus negative 45 meters. So positive 50 plus a negative 45 meters is going to tell me that I wound up plus 5 meters in the x direction, or we said plus is the same thing as saying that we headed east. So 5 meters east. So my final calculations were off by 10 meters to the north and 5 meters to the east. Okay? Now, taking that one step further, if I had to redraw what that looked like on an XY axis, and I said 5 meters to the east, keeping in mind that direction's east. Okay, let's say that I went 5 meters this way. And I headed 10 meters to the north. When I draw this out, I have to draw the arrow so that the tail of one arrow is touching the tip of the next. So tip to tail. Okay, and this one was 10 meters north or 10 meters up. Well, how far is that overall? It's not like I necessarily walked this way and then this way. Maybe I just took a straight line path. Remember, total displacement is a straight line path. Okay. Oh, kind of looks like a right triangle, right? So, if I take this to be a 90 degrees, because it's 90 degrees between east and north, right? So that would be my 90 degree angle. So if that's a 90 degree triangle, I have a hypotenuse, and I have one leg and the other leg, right? And that's really not drawn to scale, sorry. Okay, but I could figure out how far this is here, and that's my overall displacement. My net displacement. Okay, so for my net displacement, I could use the Pythagorean theorem. A squared plus b squared equals c squared. Okay, so that's my A, my B, and that's my C. And some of you might be asking, wait, I thought she said it has to be tip to tail for the arrows. Why is that one tail to tail and that one tip to tip? We draw our net displacement, gets drawn tail to tail and tip to tip. That's the only one that gets drawn that way. Okay, so let's say we needed to find our net displacement. I'm going to abbreviate net displacement equals, well, how would I do that? I'm going to go a squared plus b squared equals c squared. So let's call displacement d. Displacement squared equals 5 meters squared plus 10 meters squared. So d squared equals 25 plus 100, right? 125 meters squared. If I need to get d by itself, I'm going to take the square root of each side. Square root of d squared equals the square root of 125 meters squared, and that gives me d equals, what's the square root of 125? Put it in your calculators. It doesn't matter if it's not perfect, right? I only care about sig figs to the point that we're not going to go crazy with people questioning how we're rounding things. Okay, so technically it would have to be to 1 sig fig, but that's kind of obnoxious. So we're just going to say 11.1 meters. That's reasonable. Rounding to the 10th place is completely reasonable. Okay, so our total displacement is 11.1 meters. Now what happens if our displacement was south and west at the end? Because then we get something kind of weird, right? Let's say that I had gone, 90 meters north to start with. So I traveled 90 meters north, and then I said, I went 45 meters east, right? Let's mark these on here, east, west, and then north, south. Okay, what if I then turned around and I kept walking, and when I calculated it out, I said, oh wait, I want 100 meters south. And I went 50 meters west. Well, that's kind of weird, right? Now I'm down here in this corner. So theoretically, I wound up southwest of Route 55, because remember, Route 55 is right here at the origin. Okay, so if I miscalculated that way, well, then I'm off the other direction. So if I took my y-axis and I wanted to know how far off that way I was, well, north is still positive, plus 90 meters, plus negative 100 meters. So I have a net of negative 10 meters in the y direction, or 10 meters south. For the x direction, I walked 45 meters east, which is a positive, right? Plus 50 meters, which is, this is to the west, so that's a negative, minus 50 meters. So I have a net of negative 5 meters, or 5 meters to the west. Well, now what the heck happens when I do this triangle? Well, let's see. If I wanted to pull this out and redraw it for the sake of figuring out my net displacement, remember, now I have to go 10 meters to the south from Route 55. So let's say I went 10 meters south. And I went 5 meters west. Okay. And I need my net displacement right there. Draw that in purple. Okay. So how do I find that? Well, let's do our ABC triangle again, right? I'm going to pull it out to the side. I'm going to say that one was 10 meters straight down, 5 meters, once again my scaling is terrible here, okay, 5 meters to the west, 10 meters to the south, and that is our 90-degree angle, right? Okay, so how do I find this side, our net displacement? Well, same thing, right? It's not like suddenly that negative that we found up here, the negative 5 meters, the negative 10 meters, they disappear when we redraw it. And even if they didn't, when we square it for the Pythagorean theorem, they would disappear because they're squared. So if I want to find D, which is that hypotenuse, I'm going to say D squared equals 5 meters squared plus 10 meters squared. So D squared equals, well, it's 125 meters squared again. Take the square root of both sides again. Wait, the distance is still 11.1 meters. So what's the difference from here? Well, the 11.1 meters is 11.1 meters to the southwest. Okay, so it's just that now I'm in the southwest quadrant. Before I was in the northeast quadrant. So I just need to be able to decide which quadrant I'm in. If you guys are planning on taking AP or CP physics next year, then I'm going to show you how to calculate an angle in here. But that will be on a separate video only for people who are interested in doing that, or potentially for extra credit. It's not necessary for this class. For this class, you need to be able to find the hypotenuse, so the net displacement, and you need to be able to tell me which quadrant it's in. Okay, southwest, southeast is in this corner, right? Northwest, and northeast. And you can think about a map. If you think about a map of the US, that should hopefully make sense out of that one. Okay, don't stress out too bad about it. Try to get as finished up with your lab as you possibly can. I will be returning hopefully on Wednesday. I'm hoping that they let me out from jury duty. And I will see you guys then. And you're going to complete the lab as far as you can, and you'll have your textbook vocab words from chapter 3. Thank you.